already know your question. 91.
Yeah, what happened?
You guys are funny because I totally said everything but word problems. But okay, 91.
Oh,
What else?
49.
49. Cool.
101.
Yeah, I know, ironic, huh?
Oh, I'm sorry.
We apologize.
Me too, easy. Sorry.
That's okay. Let's go ahead and take the evens then.
I just have.
Wait, 91 is not a word problem.
71, there is no 71 kid. What?
72.
Oh, that's an even. That's an even. We haven't checked them yet, so we don't know. And remember evens, I usually talk through, and why do I talk through evens?
They're hard.
Because they don't have the answers in the back of the book. Evens are theoretically very similar to odds. Some are hard, some are easy. But the evens you haven't been able to check yet, unless you went on Slater or something, and they're quite frequently wrong, to be honest. So, coming back, the evens, it's your chance to grade as like little baby quizzes. I had odds, I tried odds, I missed odds, I calc-chatted odds. Could I do the even? Does that make sense?
Yes.
We've talked about this many, many times. So these are little quizzes, and so if you need to mark something wrong on an even, I want you to have immediate feedback for what went wrong. And to be able to ask me if you aren't able to understand what your work or how your work was wrong. Now, if you just leave an even blank because you're lazy and don't want to try it, you shortcut the whole process and you're not going to learn from it. You're just going to copy down an answer and be like, hey, I did it. No, I didn't. And that's your choice, and it's going to bite you in the butt. Maybe it already did. It's true, right? It's true. If you're not trying in your homework, it's true. But the evens, let's go ahead and talk through the evens. There are other odd questions.
It's just like a mini one on 35. I just want to know how to graph
Okay,
it.
catch me when we get close then.
Okay.
Okay, so for number 2, we have initial and then terminal. We talked about this in class, right? Initial, terminal. You could have said final also, that's fine. You could have said tail and head, also cool. Number 2, multiplication then addition. Number 14, the initial point was 0, 0. The terminal point was -4, -2. You had to subtract them like we learned, final minus initial. And you got your components. From the components, Pythagorean, you got your magnitude. Now pause. Pause. If you got root 20, good job. But you guys should know how to simplify a radical, right? Root 20 is root 4 times root 5. Square root of 4 is 2. Number 22, super similar. You have your initial, terminal, you subtract to get your components, you do Pythagorean theorem, and simplify the radical to get 8 roots. Couple more seconds. Remember, if you're marking something wrong right now, it could just be a little mistake and you can go back and check it out. And if, while we're doing odd questions, you guys aren't able to find your mistake on even, let me know. Okay, now we're in the 40s, but Chris, you had a question on the 30s. Let's go look at number, what did you say, 35?
Yeah, 35. I just wanted to know how
That was
I
on the
would
next
graph
page.
it.
Okay.
Or sketches.
35, when it says make a sketch of each resultant vector. First of all, do you know how to sketch the original vectors just by going from the origin? Let's see. For I plus j, it'd be 1 and 1. There'd be your vector, right? For this one, 2i, 1, 2, -3j. That would be your v vector, right?
Right.
Okay. What happened when you added u plus v? What were the components? Or what was the vector of the sum?
When you added them, it was 3i and -2j.
Okay. So 3i and -2j. Use the exact same procedure. They just want the resultant.
Oh, okay, great.
So you could have done the whole, like, show the one, show the other, do the shifty thingy, and connect. But they just said to sketch the resultant, so there it is. That's good. Good question. Now we're up to the 40s. For number 42 for you guys to check. And then we start getting close to our first odd question on 49 and then 63. So number 42, I'll give you a second. I can tell from the math they're doing a unit vector, right? And unit vectors, you did that multiple times in class. Unit vectors, you take the original components and you divide by magnitude. They found the magnitude to be 13. So they divided 5 by 13 and -12 by 13. And guys, you have the directions written down. This is not the answer. This is you following the direction of This is the answer. This was you following the direction to CHECK. Check. Wasn't that in the directions to check?
Yeah.
Because if this is right, what should the magnitude be?
1.
That was just checking. The final answer is 513, negative 1213. You guys had a question on number 49, so we're going to go peek at that. Some of you are already looking at 54, linear combination form, but what was number 49? 49 gave us, okay, he was weird. Yeah. And then, like, a lot of your groups had a question on that, right? Does that make you guys feel a little better that a lot of your groups had that same question? Does that give you a little more confidence to ask me that question? Good job.
Thanks, yeah.
It was weird. That's okay. There's no shame in asking any question, but if you guys feel better, because a lot of people have the same question, okay, cool. Number 49. Find the vector v. Basically, I know u's components, but I don't know v's. Does that make sense?
Yeah.
So, I need to find v's. I know v's magnitude. I know he's in the same direction as u. So think of it this way. Couldn't I draw u similar to how I just drew that one? Couldn't I draw you by going left 3 and up 4 and say, well, there's u? Would you guys agree?
Yes.
Okay. I need v to go that same way, but he either has to go longer or he has to go shorter because he has to go 10. Well, how can I compare 10 with this guy? Now let's figure out how long this guy is. And then figure out how long u is. The formula for magnitude. What's the formula for magnitude? Negative 3 squared is 9, right? 4 squared is 16? That's 25. What's the square root of 25?
5. No way.
Oh, he's 5. I need him to be 10. How do I make a 5 into a 10? Double it. And if I'm doubling the diagonal, what else am I doubling? Dun, 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 dun. It was so easy, but it was hard. If you need it to be a length of 10, and it's only, you had to find the magnitude, a length of 5, double it, done. Tricky, think outside the box a little bit. Some of you, maybe the picture helps. I got this guy and I need, but do I go shorter? Do I go longer? We had to compare, and the only way to compare is to say, he's a 10. Who's he? Oh, he's a 5. Double. You guys also had a question on 63, but there's an even before that. Number 54, wasn't it just final minus initial? Components and then linear combination form? Some of these are really easy, right? Just a few.
So going back to like number 22 and stuff,
Okay.
like if we didn't simplify the square root, like from square root of 1.8 to a square root of 2, like should we mark out like half a point, or like how do you want us to?
Don't worry about marking off as far as points, but I would make a note of it in your colored pen, because that way, when you're studying for a test, right? Think of it this way: the multiple choice is going to have it nice and simple.
Yeah.
Okay. And if you and your brain are used to staying there and being like it's good enough, the problem is when you get to that multiple choice question and they simplify, you won't be able to make it match. So I would just write it in colored pen, put a little star, and say remember to simplify.
Okay.
Yeah, so don't stress that. When you guys mark down, remember, you're not taking away points from yourselves. You're saying, hey, remember to. Is that cool?
Mm-hmm.
Okay. Let's go back to that number 54, although I think we got him and he was pretty easy. Your guys' next question was on, like, what, 63, I think? Look, it was working. Okay, anyway, let's come back. You guys can go ahead and check number 72. Let me get 63. I know that you had a question on it. I apologize, my PDF decided just to hate life. Which we understand. Sometimes life is hard, but still. I'll see if I can get him to work again, but... Guys, number 72, they did not give you A and B. So, question, how did they magically, it wasn't magic, how'd they get the A and B if it wasn't given to you? Yeah, what were those formulas again? Good. Magnitude, cosine, angle? Magnitude. Uh-huh. And what is cosine of 90?
0.
And what's sine of 90?
1.
Perfect. And then if you sketched it, it's 0, and then up 4 root 3. It's just a straight up vector. Number 63. Okay, right now the book's working. Let's see if it keeps working. 63 you guys had a question on, and 63 gave you... Oh, it just doesn't like the word problem page. Okay, anyway. 63, it works opposite. In the next one, in number 72 that you guys were just grading, it gave you, Despicable Me, it gave you magnitude and direction, and you had to find A and B. Number 63 gave you A and B. How do you find magnitude and direction? Pause, open your notes. Come on. Yesterday, remember that page of 4 formulas I had you boxed yesterday? Go find it, because those formulas, that page said, hey, they give you magnitude direction? Cool. You can find AB. They give you AB? Cool. You can find magnitude and direction. It's the one where we were writing theta yesterday. There were 4 formulas that we boxed. Maybe you boxed 3. We wrote down Pythagorean also. Who can find me a formula to find the magnitude when given A and B? Oh, no, magnitude. Yeah, magnitude. That's just Pythagorean theorem. Hold on, listen to the words. You gotta know the vocab, just like in class. Magnitude of V is A squared plus B squared. So that's going to be 36 plus 36. Which, Joel, here's that thing that we were talking about. 72 is root 9 times root 8. Root 8 is root 4 times root 2, right?
Mm-hmm. And square root of 96.
I know that, and I know this. And he's stuck. So there's magnitude. Now you guys were trying to help me out with the other formula, which is good. I need it. How do you find direction angle? Yeah, inverse of tangent. Of who over who?
B over A.
B, negative 6 over A. And here's the crazy thing. If you plug that into your calculator, if it was in degree mode, you would get negative 45. Struggle. Look at your notes. We said use tangent, inverse, and a
Picture.
because. Graph this guy. Positive 6 and then negative 6. What quadrant is he in?
4.
Okay. What angle, or what quadrant is this angle in? Oh, does it match up?
Yeah.
Does it always? No. Does it this time? Yes.
Yes.
So can I use the negative 45? Yes. But I do believe the back of the book probably liked a positive angle better than a negative. Do you guys agree with me if we check that on?
Mm-hmm.
And if they like the positive angle better, what other angle represents negative 45? What's another way of getting there? Can't we add 360? So if we add 360 to 45, we get the positive angle they like, which would end up being 315. Same location. The negative 45 wouldn't be wrong, but would you be able to match that 315 also?
Yes.
That was number 63. That was that odd question that you guys had. 3, we've done 72 as an even. I know we have 74 as well. What was our next question? 85, and then our 2 word problems that are odds, right? Okay. Number 96. Ooh, wasn't he an inclined plane one? I think he was. So you were able to use that triangle that we wrote down yesterday with the gravity going straight down and the perpendicular kind of going diagonal. And then the force or the tension, the force, needed to pull. So you would have needed to use your picture that we saw yesterday. Ooh, that's not correct though. I apologize. Gravity straight down, perpendicular, and then tension. There's your writing. And I can just tell from what they showed you that they said that the incline was 14 degrees. And whenever the incline is 14, you throw that into our little triangle in the incline. They also told us that the force needed to pull was 600. That's why the opposite side is 600. So you need to pull the object up the slope. It's that vector. And they're asking us for the weight, the combined weight. So what related? Angle with opposite and hypotenuse, because it's across from the 90. Sine. They plugged in. Labeled it pounds because that's what the force that they gave you was measured in pounds. Okay, number 85. Let's go peek at that last odd one. Non-word problem odd one that you guys had a question on. Well, that didn't work. Let me get to your notes. Because now the book got mad. Okay, number 85. Is that the weird cable-y one? This is the first word problem. Oh, it's a hook. Okay, it's not as bad as I thought. This is the hook one, a chain through a hook, right? Alright. So number 85, this is very helpful to look at the picture. You have a chain going through the hook. And as there is force being put on that chain, it's pulling in two different directions. They tell us that forces with magnitudes of 125 and 300 newtons. Okay, hold on. So one of these needs to be shorter, 125. And one needs to be about 3 times longer. So there's our 125. And here's our 300. Guys, newtons usually is written with a capital N. Don't worry, you didn't need to know that. It's a physics thing. But newtons is just another way of measuring force. They tell us the angle between them is 45 degrees. The angle between them is 45 degrees. And then they want us to find, this is number 85, the magnitude and the direction of the resultant. Now, help out. I've used this word many times. What are they talking about with resultant? The net. And you find the net by adding. Good. So really what they're wanting is the sum of, we could call this one, I don't know, U. We could call this one V. What they really want is U plus V. They want the resultant, they want the sum, they want the net force of the two put together on the hook. Long story short, there are two different things going on with the hook and the hook handle it. That's maybe one way of looking at why they would care about the sum. Yesterday, we said there were two different ways to solve a problem like this. One way is the geometry way, and one way is the component way. What do you guys want to do? Most people would say component. Geometry people, you would just need to think of shifting, connecting, parallelogram idea, and then solving the triangle with law of cosines, law of sines. Component people, well, do we have components yet? Okay, it was tricky to get them, but let's think about it. We need magnitude cosine angle, magnitude sine angle. So for you, it's easy. We have 300 cosine of somebody and 300 sine of somebody. Question, what's U's angle if it's straight that direction? Zero. Because U hasn't rotated at all. U itself just has an angle of 0. Now, who's at 45 degrees? V is at 45 degrees, but U's not. So V I could put with cosine of 45. But U, I'm just going to put 0. Because U hasn't rotated. Then we go ahead and just add the thing together, and then we get U plus V. And guys, didn't we talk about how you just need to put this whole thing into your calculator and add? Get a decimal, add, get a decimal. Can I just say A and B for right now since it's an odd? So you would add and get A, add and get B. And then guys, how would you get magnitude?
These A squared, that's root of A squared plus B squared.
How would you do direction?
Inverse B over A.
And then isn't this just well, if you want to see the picture to help you out a little bit, we would move the U up. There's the sum, he's my U plus V. But either way, isn't that going to be a nice little first quadrant angle? guess what? That's gonna be perfect. You're not gonna have to do anything weird. The nice little first quadrant angle, and so the calculator will get you exactly what you need. Okay, so I'm done. All right, your questions on? Oh, that was the last, okay, that was the last even. Let's go ahead and get rid of the evens. Help me out with the numbers of the odds. 91, was he a tensiony one?
Yes. Yeah.
Oh. He was the cable one. Okay, I technically have this whole problem with cranes. He was actually number 89 in your book. But instead of doing the crane one, let's just do the tension for 91, the homework problem that you guys had. We're going to save some time. And I already told you yesterday, tension would not be on the test. It's a great idea, it's a great concept, great application, but not on the test. So as I get ready for 91, Josh, go ahead and go. What's up? Yeah. 91, we have two pulleys, right? And you have a cable that's going through both of the pulleys and holding up 2,000 pounds. Okay. So you have pulley 1 here, we have pulley 2 here, we have like a cable that's going around, and a cable that's like going around, straight in between. Then we have here our weight of 2,000 pounds. Okay. And this is straight. Okay. What do we know about our angles? They're a little bit different, right? So here's an A, here's a B, here's a C. And then, guys, help me out real quick. What's this angle right here? It is 50. Cool. What's B? 30. Okay. We're trying to figure out the tension in each cable supporting the loads. Where's the load triangle? Or how is the tension in the cables working? Is it pushing down or is it pulling up? So I have a tension right here. And I have a tension right here. So here are my vectors. In order for this load not to be slipping, does that make sense? In order for this whole pulley system to be strong enough to uphold the load, I need the tension in these two cables. We can actually be snazzy and why not? Call it A and call it B. I need the tension in these two cables to be strong enough to equal the 2,000 pounds. Now, it doesn't need to be stronger than 2,000 pounds, although it would be great if it was. It just needs to be strong enough. And technically tension, if you think about tension isn't necessarily the max capacity of the pulley system. Tension is just currently what's going on where these cables are upholding. So basically the tension in both of the cables is going to equal to 2,000 pounds. Now, hold on. Vectors, when they're added, equals another vector. So it doesn't just equal 2,000. Actually, what it equals is a vector that has two components. Even though this load is trying to pull down, the tension in the cables is pulling up. So it needs to pull up with an equal force. But 2,000 is just vertical. It's just up, down. It's trying to pull down, the tension pulling it up, so that's why it's going to be a positive 2,000. The question, what's going on horizontally? Nothing. Oh. So I know that these two added together has to equal that guy. Where horizontally there's nothing going on, and vertically it needs to be holding up 2,000 pounds. Okay, so if that's true, wouldn't it be super nice if I could get components and just add them together? Yeah. Cool. So let's talk about components for a sec. If I can actually get my page to be long enough. Okay. I need components of A. I need components of B. I need magnitude, which I don't know. Oh. Alright, well, if I don't know something, what do I do in math? Make it a variable. So, A is going to be x times cosine of, oh, it's okay, remember the last problem, we had to kind of figure that out also? Yeah. Okay, we'll come back to that. But it's x cosine of and x sine of. Alright, we're talking about A. A is at an angle of 50 degrees, right? Mm-hmm. Here's the struggle. It's an angle of 50 degrees down from, okay, so we could put a negative 50. Or, couldn't we just make the horizontal axis there and be like, oh, hey, what would his angle be? What would his angle be if that's 50? 130. Someone knows their geometry. Why would it have to be 130? What's true about these two lines? Parallel. Or you could think, that guy's 50, alternate interior, that guy's 50, so who's the other guy? You could do it that way, 130. That's a nice standard position angle for this vector. If it was written in a nice standard position where this is the origin. Because up here is awkward. Is that the origin? Is that the origin? So if that's the A's angle, then what's the B's angle going to be? Well, hold on. Oh yeah, he's just 30. Alternate interior angles are congruent, so I could just go ahead and steal that guy and say 30. Y sine of 30. Time to add. Now here's where it gets a little bit weird. Struggle. I can't just plug that in my calculator, right? But can I actually write it and say x cosine of 130 plus y cosine of 30? Ooh, has to equal who? 0. And then can't I add these two? X sine of 130 plus y sine of 30. What does this one need to equal? It's like they think that I've done math before because, man, if I have two equations with two unknowns, what should I be able to do? Solve with substitution. Well, I mean, you could do elimination, but who wants to make these guys math? That just sounds gross. Substitution, that's a way. Or if you guys want to be super snazzy, can I make elimination work? No, I already discussed it. That's not good. So let me go ahead and do a dual page. This is about to get a little bit longer than you would probably like. There we go. So now I have to do like a substitution thing. Do you guys realize I try not to plug anything in my calculator until I have to?
Yeah.
Then I just plug it all in and be done. So here's what I'm going to do. This guy looks a little nicer to get like x or y by itself, right? Okay, so let's go ahead and just solve for x because he's the first guy I see. X is going to equal, I'm going to need to subtract that guy to the other side and divide by the thing next to x, cosine of 130. Okay, so by making this an equation, subtracting that to the other side and dividing, I have my x. Done. Once I have x, where am I going to go plug him into?
Ooh.
The second equation. So I can go ahead and plug this guy in. Negative y cosine of 30 all over cosine of 130 plus, nope. What's x being multiplied by? Okay, so I have x times sine of 130 plus y equals, alright, it's calculator time because this just got nasty. Ready? I need you guys to go ahead and plug in. What's cosine of 30 divided by cosine of 130 times sine of 130? Just get me a big old nasty decimal. There's too much going on. We just need to get some decimals now. Cosine of 30 divided by cosine of 130 times sine of 130. If you need to, if you're doing a snazzy fraction thing, that sine's on top, not on bottom. He's on top. Help you guys get all warm, and now you guys are all falling asleep.
Alright.
What decimal we got? Negative
0.532.
Okay. Give me a decimal for sine of 30. Yes, it's 0.5. Isn't it 0.5? Yeah. Oh yeah, radian would mess me all up. You need to be in degree. Why did I have you get decimals? Because kiddos, what can we do? We could just put them together. You might not have realized it here. You would have gotten all lost in all the yucky cosine signs, blah, 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 blah. But now that we have decimals, just add the two together. I get negative 0.32y is equal to 2,000. Now pause, hold on. You guys who were solving, you were in degree mode, right?
Yeah.
Okay. So to finish off, I just have to do y is equal to 6,000 what?
250. Hold on.
Now here's something that's really funny to me. Cosine in the second quadrant is a negative number. So cosine of 130 was supposed to be a negative. And when you divide a negative by a negative, you get a positive. Did you guys not put this extra negative in there? Did you get a negative from all of that?
Yeah.
Okay. Times a negative would be a positive. And the reason why that's important is because this y should have, magnitude is always positive. That's why I was like a little worried. For those of you who are solving, you got this to be a negative number. Times a negative would have been a positive. There we go. So that's the tension in y. Oh.
So, can you make it negative for 0
Yeah, that's what.
I think.
Or does that matter?
Yes, I agree.
Gracias. I did bad mental math. Thanks, Jade.
We're talking about
I think,
the number for the multiplication.
yeah, the plus 0.53.
Oh, that's what I was asking, if you guys all got the same thing. You said yeah. Okay, so let me find it. Cosine of 30 times sine of 130. Usually, if we all do it, we're doing all right, but I guess not today. I got 1.032.
Yes, okay,
Yeah.
that's not bad.
Okay, great. Now I have to do everything.
Calculator's so nice, and yet sometimes not so nice. So 1.032 plus 0.5 will end up with 1.532.
Yes.
This should make a bit more sense too.
Yeah.
That tension was super ridiculous. So 2,000 divided by my 1.532. Aha. 1305. Yes. 0.483. And I think it's going to be pounds. Because they gave us 2,000 pounds. It was hard, but it was only hard because we struggled putting in our calculators. That's a struggle. Wait. We got y. How do we get x? Look, we have a formula right there. Just saying, give me y and I'll find x. Michael, better sit up, bud. Too much temptation with the wall. Alright, so we end up with negative, that number that we just found, times cosine of 30.
Yes.
Divided by cosine of 130. Aha. Double check me. Did you guys get 1,758? 1,758.873. It was 0.872, but I think it rounds. Yeah, it rounds up. I used the full decimal. You might have used it like the round. You might have used the rounded decimal. AJ.
Just a good question. How did you get negative y before x equals?
So I had this guy plus that guy equals 0. So to solve for x, you have to subtract to the other side and then divide. Yeah.
Just, can you just restate how you got up to 30 degrees?
When both of my cables were measuring like this, they were measuring differently and I needed them to be measured together. So then I thought it'd be easier to make that the origin and then find the angles this way. To do that, I had to see these two as parallel lines with a transversal cutting. Back from geometry, we could tell that alternate interior angles are congruent, which means 30 was 30, which is why I stole them from here. But over here, they're on the same side of the transversal. So I needed to think of a different geometry property that said these two would be congruent. And since this plus that equals 180, I just did 180 minus 50 to get 130. Yeah.
Sorry. Did you use, we're trying to find the tension on the strings, right?
On the cables, yeah.
So wouldn't you have to put gravity in there somewhere?
Well, gravity, we said when the box is 2,000 pounds, the weight is taking into consideration gravity.
Okay.
And this isn't like an object in motion, it's just does that make sense?
Yeah.
Yeah, so that's not what's taking into account.
How did you get that particular y? Because I got something slightly different. Even though
Of the 1.032?
No, y equals 1,305. Something slightly different.
Well, I actually used the rounded one that people were telling me, and so if you use the fuller one, you might have been actually a little more precise there.
Yeah.
So that would be good. Yeah, that would be good. Keep your more precise answer. Kiddos, that class number 91, the one that we're going to skip for right now is the very last word problem. We might be able to come back to it. But I did want you guys to see attention one, because that was the example that we skipped yesterday, but we're not going to do that crane one since we did the cable one that you guys already kind of got stuck on in homework, which was good. I want to show you one big thing about dot products before we finish today, if I can actually get this to zoom. There we go. Because what we talked about yesterday was the fact that we can add vectors if they're in components, easy. We can subtract vectors if they're in components, easily. We can multiply by a scalar, easily. But what we said that there was no property yet for was multiplying two vectors together. And to multiply two vectors together, if you're a highlighting, starring kind of person, the rest of section 6.4 is basically like, hey, there's a new formula. Let's A, make sure we know how to do it, and B, figure out all kinds of different ways it gets applied in physics and beyond. Now, there are tons of applications of this little guy called the dot product. We're just going to see a few and basically get to practice doing dot products while we apply it. But I want you guys to at least see how the dot product works. Because the dot product says the following. If we can get our vectors into components, which we can, even if they don't give it to us. Remember, we have those formulas where we can find A and find B. Once we get vectors into components, a dot product is literally just saying multiply the horizontal components together, multiply the vertical components together, and add them. And so, if you were to get to a problem like this one, where they wanted you to find the dot product, you would say, and here's an easy way maybe to look at it. Some of you would need to write it in components, and some of you would. To find a dot product, two vectors multiplied by each other. You literally just say, oops, don't write the side caret because the dot product is not a vector. It is just a special concept. You just take the horizontals, take the verticals. That is my formula. U1 times V1 plus U2 times V2. Multiply, multiply, and then done. It's a number, it's not a vector. It's a number, not a vector. When you multiply two vectors together, you are not just extending it, you're not just flipping it, you're not just finding the resultant. Multiplication of two vectors is a special constant that will be able to be used in all sorts of application problems. But the dot product says multiply the horizontals, multiply the verticals, and add the two together and get a number, a constant. And then you're done. So, maybe you might have to do a few dot products, but all of this is just saying let's make it a little harder, but you're still doing a dot product there, and subtracting the two. A number minus a number, and you've done. So, if you guys have section 6.3 mostly attempted, which hopefully you do, we only had one question we didn't get to today, play around with this new formula just a little bit, because then you'll be ready tomorrow when it's time to use it. Sound good?
Did you know
I have a dentist appointment, so I need to be out of here by tomorrow. I'll be here.
Did you know that we still have to
Oh, I forgot. Let's just say our test average in this period is lower than any other period. So we need to get our test average up before we have fun things again. And so I'm going to reward someone with a higher test average.
Abby has always
Right.